My name is Ahmed Eldyasti. I'm assistant professor here at Civil Engineering at Lausanne School of Engineering, York University. I finished my PhD at University of Western Ontario, back in London, Ontario, and then I work in industry for a few months, and then I joined here as assistant professor working in environmental engineering area. I decided to go with civil engineering at the beginning because I love to work on sites and in construction and so on. But what's turned to be actually, once I finished my degree and then I start working in research, I found the area of environmental engineering is actually something very interesting to me. It's still you go to sites, but in this case you go to wastewater treatment plants or industrial treatment plants that they are looking to build an environmental engineering system in order to protect our environment. And that's actually where I got more interested, and I did my master's degree and then my PhD towards this area of research, focusing to improve the environment for people, because this is always my hope, is to focusing from engineering perspective to help people. And one way to help them is actually to protect the environment for them, to generate or recover energy from what we are wasting every single day. What we're trying to do here in my research is to use the wastewater as a resources. And when I'm saying resources, not only recover bioenergy, biohydrogen, biomethane is not only the case, it's actually we're focusing in even recover toxic material or pharmaceutical material from wastewater, also recover polymers that can be used for biodegradable plastic. The other area of interest to us is actually working to make the existing wastewater treatment more efficient. And we have a project right now that's focusing in the aeration system for wastewater. We're trying to get it more efficient in order to have a higher, what they call it, oxygen transfer efficiency to the bacteria. One of the things that we were talking about is basically the gas meter, the 3D printer gas meter, and this is what we have here. This is one example that we developed from scratch. It's just printed in a 3D printer in a way that's going to count how much gas that's produced from the bacteria. And basically, as you can see here, there is a hole at the bottom of this triangle, and the gases start to replace the water, trying to push this triangle to the other side. Once it's pushing to the other side, what happens is basically you are actually getting one tip that's counted to the counter here. And by the end of the day, if you have something like 339 and you knew how much tip that we calibrated at the beginning of the experiment, then we knew how much gas that was produced from the bacteria per day. And basically we transfer or we calculate accordingly what's the performance coming out from this as a biogas and what's actually the performance coming as a degradation of organics and solids and so on. And in that way, you have a sustainable way of monitoring your bioreactors in a way that you can actually do it in an economical way, and it's still very accurate and very precise to figure out whether the bacteria is working or not. When you look into the environment and you heard about climate change, everyone is talking about climate change, but the reality is there is really something happening to the environment, because we have seen over a number of years right now how the winter is changing, how the summer is changing. Now you start hearing a warning, there is an ozone level, blah blah. There is a number of things that's happening from the environment. The ultimate goal, or the reason why I'm focusing on this, is to help the next number of generations to build their environment in a more sustainable way and in a more safer way. And at the same time, try to get more money out of what we are calling right now waste. That's the ultimate goal.